What's up, everybody? It's been a long time. So now we're going to talk about something called Chetaev Instability Theorem. And if you have a system where you want to prove the instability of the system, that's you can use it. Is a type of theorem that is easier to satisfy compared to like other Lyapunov instability theorems, right? And usually we would be interested in proving the stability of a given dynamical system. But now we will look at the question from another side, right? So, okay, this is the example problem. And before moving forward, let me note, all right, get your attention to the following. So, this is like the sixth power. So, very huge number, right? And we can say that for x1 very small x1 and x2, right, terms, the dynamical system can be approximated by this, right? It couldn't be a stretch to make that statement. And it is obvious that by looking at the dynamics of the second state, which is interesting enough decoupled, we can see that it is unstable. All right, so directly we can say that, right, without even looking at the Chetaev theorem. But although this is a simple example, this is an illustrative one. So let's use the Chetaev instability theorem for the given dynamical system to prove it is instability. So what are the requirements? We have two requirements. Again, we will have like Lyapunov like function, and that function is, so for a given set D here in this case, for a given D, v of x must be positive on that D except for the equilibrium point, which I indicated as 0. Alright, so but instead of looking at a region, right, where a neighborhood also includes rather the neighborhood of the equilibrium containing the set, this is what we would have if we were dealing with a Lyapunov function and like proving the stability of a given dynamical system. And so this is fundamentally different. And you can also notice that it would be easier to satisfy, right? All right, let's move on. So we will have some type of region, all right? Let me here. This is the equilibrium point. And equilibrium point will be on the boundary of that set. All right. And they sometimes say that like also the boundary takes the value 0. Okay. Which I indicated as the blue color. All right, this is the requirement number 1. Let's look at the requirement number 2. Again, we need to compute v dot. Once we have that v of x, we will compute v dot, which is the type of operation that we would do in, Lyapunov, like finding that v and then taking derivative, right, with respect to the dynamics, along the dynamics, and computing v dot. So it is similar again. All right, v dot of x must be positive, not on the whole D set, on a set which is, that can be stated as neighborhood of the equilibrium point, neighborhood of the equilibrium point. All right, let me denote it by n, let's say n, right, intersection with the original, the first stated set D. So it must be positive on this set, which I indicated with blue color here. Right? So these are the requirements, and for the system, we will use v of x equals I think that was it. Alright, we will use that, and I have the Python code. Now I'm gonna represent the plots. It is obvious that this is positive. In fact, for our given x and x1 and x2, and now we need to compute x dot. We will compute that, and then once we compute it, we will look at for given x1 min, x1 max, and x2 max and x2 min values. We will plot that, alright, and we will use some type of color coding. For positive values, we will represent the point with red color, and for negative values with blue color. And here I mean x1, x2, and these points is like basically the sign of v of x. This is the v dot, sorry, not v dot, right? And if we see something like this, for example, then we will conclude that, and okay, this is like negative values, alright? We will conclude that the system is unstable. Alright, let's check the MATLAB code. No, I mean, there's also a MATLAB code. I will please look at the description below. I will include, I hope I wouldn't forget, I will include GitHub link, and where you will be able to see and download MATLAB code and Python code, right? Right, I'm gonna show them. Okay, this is the Python code. I will include it, and right, this is the V that we used, and this is the dynamics. This is the dynamics. All right, everything is going bad, by the way, since I'm recording. No one called me, but since I started the video, everyone started calling me, so that's great. And literally Murphy as well. And we can look at the V dot, and here we can see V dot being positive. This is red color. And by the way, now I noticed that I made a mistake in my earlier statement that this is not negative, this was positive. Okay, that's it. Alright, and so here we can see V dot, this red region is the region where V dot of x1, x2 takes the positive values, and here this is the equilibrium point. So there is a region, there is a neighborhood, there is a neighborhood such that neighborhood intersection with the D set, which we can at this point define as this set or this set, it doesn't matter, because why? Our v of x is, for our given x1 and x2, is positive. It's a positive function, so we have that flexibility now. By looking at that, we can say that the system is unstable. Alright, so thanks for watching, and don't forget to subscribe by this. Alright, have a nice one.